What's that?
So the last 1% is
Okay, calculate the velocity of a spherical raindrop would achieve falling from 5 kilometers in the absence of air drag with air drag. Okay. Take this. Okay, so in the absence of air drag, A will be equal to G, and if this were 5 kilometers, the final velocity would be, okay, V square would be V naught square plus 2A x minus x naught. V would be, we'll assume it starts at rest, okay, 2A x minus x naught. So this would be 2 times 9.8 times 5,000 meters. Okay, and this will work out too. (313 meters per second). Okay, the speed of sound is 340 meters per second. So it's traveling at 0.9 the speed of sound. Okay, so at least you won't have a sonic boom, all right, when it rains. But you definitely don't want to be there. 10 meters per second is 25 miles an hour roughly, so this is roughly 750 miles an hour. Speed of sound is 750 miles an hour. So it's roughly about 650 miles an hour. These are bullets coming at you at 650 miles an hour. Okay, you don't want that. Okay, with air drag present, the terminal velocity. Okay, somebody look up the formula for the terminal velocity real quick. I have 1% left. A. Okay. Okay, so this is what these things are. Our mg is the weight of the thing, c is the drag coefficient, rho is the density of water, and a is the area of cross section. Okay, and do they give you c with air drag? The size of the drop to be 4 millimeters. So diameter is, the density is that, and the surface area to be pi r square. Okay, area of cross section is pi r square. R is 2 millimeters. They don't give you C in the problem. We'll have to assume C. For a spherical drop, we'll assume C to be roughly half. Okay, so that's what we'll assume. So here's what air drag does for you. Oh, shoot. Mass is density times volume. I'm doing this real fast. You guys can there's mass, there's G, C, rho, pi r square. Okay, the rho cancels, that cancels, r square cancels that. Okay, so this, oh, good thing, 8 by 8 GR divided by 3C. That's what it simplifies to. Okay, assuming I did it right. Which is always not necessarily true, but yes, sir. I'm sorry?
What generation?
Oh, but I'll finish before I'll be done. This is almost done. 8 into 9.8. The radius is 2 millimeters. And we said C is half, 3 times 0.5. Okay, we assume C. Okay, I messed up someplace. Is that formula correct? Here's the. Okay, I'm sorry. Here's the problem. This is the density of water, and the darn thing is falling through air. So this is the density of air. There's the problem. Okay. So those densities don't cancel. So this expression has to be fixed. So okay, so it's essentially the same thing. Oh, sorry. All right, I'll fix that and I'll post it. Okay, but you guys should you already know all the arguments. What problem was that? 84.